Yes, student, today I have defined you the Fourier transform. Yes, first I have defined you the definition. Okay, the Fourier transform, which is defined as for the interval minus, just like this is defined as you earlier in my video lectures, Laplace transform. Similarly, for the Fourier transform, yes, the function f of x defined in minus infinity to infinity for every x, the function f of x defined in this interval minus infinity to infinity, then the Fourier of the function f of x, that is f of x, this is as defined as f of p, and which is equal to f means in Fourier form for f of p. Yes, this is minus infinity to infinity f e to the power, yes, I px f of x dx. This is the definition of the Fourier transform. Yes, and therefore the function, this is known as the Fourier transform f of p, f of x, that is Fourier of this is known as, and therefore for the inverse, yes, inverse Fourier transform, that is f of x, this is equal to, yes, f inverse, yes, f of p. This is, you know, that the inverse Fourier transform. Yes, or you can say that inverse Fourier transform f inverse f of p, or you in that form you can also say that this is also akin f inverse of f of p in Fourier transform. Okay, this implies that so f of x can be defined as the Fourier transform according to definition. This is defined as f of inverse, yes, f of inverse f of p. This is again is equal to 1 by 2 pi minus infinity to infinity e to the power minus I px f of p dp in inverse form. That is the function. Yes, or you say that f of x is equal to in that form. Yes, similarly for here. This is the main definition for the Fourier transform. Now, similarly for the Fourier sine and cosine transform, yes, yes, you can say that defined as the Fourier sine transform, yes, Fourier sine transform, yes, yes, Fourier sine transform we can also define it for the infinite Fourier sine series. Yes, this is defined for f of s, we use a symbol f of s just like, yes, for the Fourier sine series f of x, yes, this is defined as for the f of x, that is in for the sine series, yes, this is defined as f of x, which is equal to f of, yes, s p, which is equal to, yes, f of sine series, and this again is equal to 0 to infinity f of x sine px dx. This is the Fourier sine transform. And similarly you can obtain the for the interval here the function here for the transform here f of x in the you have choose the function f of x in 0 and infinity, this one. And also you can also find out the inversion formula. Yes, that is now the inversion formula. Yes, the inversion formula which is given as for f of x, yes, which is equal to f of inverse s, f of s p, yes, which is again is equal to 2 by pi 0 to infinity f of s p sine px dp, sorry, yes, px and dp. Yes, this is the sign for the inversion formula. This is similarly for f of s, this can be also defined as, okay. And as the Fourier cosine transform, yes, Fourier cosine transform, and that is, yes, for f of x, the function f of x in the interval, yes, 0 infinity is defined as, which is defined as cosine means fc f of x for cosine series, yes, which is defined as f of c, yes, f of x, which is equal to f of c p, and which is equal to, yes, f of c p, and which is again is equal to 0 to infinity f of x cos px dx. Yes, and similarly for the inversion formula cosine series, yes, yes, the inversion, yes, inversion formula, yes, which can be defined as f of x, which is equal to f of inverse, yes, c, that is f of, yes, this is f of c p, or you say that f inverse c f of c p, this again is equal to, yes, 0 to infinity, yes, f of, for this formula this can be written as f of c. Similarly here is for the cosine formula, similarly this can be written as f of c, yes, p cos px and dp, or you say that f of small f of cp cos of s ds. Yes, this is the inversion formula for the, this is again for the formula for the cosine series. This is the formula for, so this is the formula, and just like this one, this can be again be written as, this again can be written as 2 by, yes, here is also 2 by pi, 2 by pi, yes, 0 to infinity, yes, f of c cos px dp. Yes, for the cosine and sine, you use these formula. For these are the, actually these formulas are inversion formula. Yes, student, you have cleared it. Yes, all these terms you clear it. These are the formulas for the cosine and Fourier series. Yes, student, you have cleared it. Okay, and next time I have defined you some relation between the Fourier and Laplace series. Okay, student, we have defined only the definition of this. what is Fourier transform and Fourier sine transform, Fourier cosine transform, and also the inversion formula of this one. Okay, thank you. Next time I have to find you the relation between these. Okay, yes friends, thank you.